In the Orion constellation resides a star that has intrigued astronomers for centuries. This star, known as Betelgeuse, is a red giant vastly larger and more massive than our Sun. However, in recent times Betelgeuse has exhibited unusual behavior, dimming significantly and experiencing violent oscillations. These phenomena have sparked theories suggesting that this star may soon undergo a supernova explosion. But what if we are witnessing the onset of something even more terrifying? What if Betelgeuse is not heading toward an explosion but instead toward a collapse within itself? Join us as we embark on a journey to the shoulder of Orion's hunter, examining these changes in Betelgeuse in detail and exploring the potential impacts for Earth. Betelgeuse is an incredibly massive star, approximately 1,000 times larger than our Sun. While its grandeur is awe-inspiring, it also carries the destiny of massive stars, a finite lifespan that could trigger a catastrophic supernova. The uncertainty lies in the exact moment of this inevitable collapse, making it a cosmic time bomb, a mystery to scientists. Situated just 650 light-years away, Betelgeuse has captured the attention of astronomers with its radiance. We marvel at its brilliance while trying to decipher the mysteries concealed in its fiery depths. Surprisingly, only about 13% of its total energy is visible to us. If we could witness its full glory, it would outshine even Sirius, the brightest star in our night sky. A star of colossal proportions. Picture a colossal star with a radius 1,000 times that of our Sun, extending past the asteroid belt, almost touching Jupiter. Within this vast space, Earth, Mars, Mercury, and Venus would be swallowed by the irresistible cosmic pull of Betelgeuse. But the intrigue doesn't end there. Every millennium, this star sheds a solar mass, creating a spectacular nebula. This nebula, 250 times larger than the star itself, envelopes Betelgeuse in an ethereal mist, stretching its reach up to 30 astronomical units. It invites us to observe a cosmic dance of wonders, revealing its deepest secrets. At the core of Betelgeuse, hydrogen fusion is at work, where helium ignites in a cosmic explosion. Over time, the star's hydrogen supply is exhausted, triggering a celestial transformation. The star begins fusing carbon, unleashing a brilliant glow across the cosmos. However, this fusion process has its limits. When iron forms, the star undergoes a critical shift. Its gravitational pull diminishes, causing an inevitable collapse, sending Betelgeuse toward a fate that is both awe-inspiring and destructive, a supernova explosion. This colossal celestial event would release energy equal to 10 billion suns, producing unimaginable power that resonates throughout the universe. Betelgeuse through history. Stars undergo an incredible evolution, shifting from their youthful blue hues to the fiery reds of maturity. In the 2nd century BC, Chinese stargazers made a fascinating observation: the distinctive red color of Betelgeuse. This set it apart in the celestial tapestry. Eventually, this observation reached the keen eyes of the Greco-Roman astronomer Ptolemy in the 2nd century AD, who recorded Betelgeuse as having an orange or reddish appearance. This feature continues to capture our attention today. The consistent red coloration of Betelgeuse throughout various civilizations, including those of the medieval Middle East, adds to the allure of its enigmatic nature. A star's strange behavior. The narrative of Betelgeuse takes a surprising turn when we examine its recent behavior. In 2019, the star puzzled scientists by suddenly dimming in brightness. Initially, it was believed that a large dust cloud shed from the star's surface was blocking our view. However, the origin of this dust cloud remains unclear. Some scientists speculate that a large object, such as a planet, may have disturbed the star's surface or even been absorbed by it. More recently, Betelgeuse has exhibited an increase in brightness, reaching about 50% of its average luminosity. This is unexpected, as stars generally become dimmer as they age. Scientists are uncertain of the cause behind this increase in brightness, though they understand that stars can experience fluctuations in luminosity for a variety of reasons. Some stars, such as Mira, known as the Wonder Star, go through cycles of expanding and contracting, affecting their luminosity. This phenomenon is common among many stars, including Epsilon Orionis and others visible to the naked eye. Is Betelgeuse's supernova already happening? In the core of Betelgeuse, a seismic shift is taking place as material is ejected into space, forming a magnificent dust cloud. This celestial dust obscures a significant portion of Betelgeuse's radiant light, transforming it from a glowing beacon to a dimmer luminary in the night sky. Recently, Betelgeuse has defied expectations, leaving scientists baffled. Various theories attempt to explain these dramatic fluctuations, from massive sunspots to dust clouds or even coinciding stellar cycles. A fascinating theory has emerged: Betelgeuse's supernova may have already occurred. Yes, you read that correctly. While previous projections suggested that a supernova would take place hundreds of thousands of years from now, there is evidence pointing to a different reality. Some scientists believe that a supernova has already happened in our galaxy centuries ago, much like the Kepler supernova. Researchers suggest that Betelgeuse is in the final stages of carbon burning, meaning it could be on the cusp of an immense explosion. This makes Betelgeuse a strong candidate for the next supernova in the Milky Way galaxy, marking the grand finale of a cosmic symphony. The mystery continues. Understanding Betelgeuse is akin to solving a puzzle. Scientists continue to monitor its every fluctuation, knowing that even the smallest change can provide insight into its final moments. A supernova explosion would be incredibly bright, potentially outshining the moon and even being visible during the day. However, predicting Betelgeuse's fate remains an ongoing mystery. Some speculate that Betelgeuse's behavior may serve as a warning sign not just for astronomers but for the entire Milky Way. While Earth is far enough away to avoid direct harm, the explosion could send waves of radiation that might influence surrounding stars and interstellar matter. For now, Betelgeuse remains a cosmic enigma, challenging our understanding of stellar evolution. As we continue to study and observe, we may one day unlock the secrets of this incredible celestial body. Will Betelgeuse explode in a dazzling display of light and energy? Or will it collapse, quietly rewriting what we know about dying stars? Only time will tell. The aftermath of Betelgeuse's supernova. If Betelgeuse does indeed explode in a supernova, the event will be nothing short of spectacular. The explosion would release an immense shockwave, sending ripples through the interstellar medium and potentially triggering the birth of new stars. Supernovae are not just cosmic destructions, they are also the catalysts for creation. The shockwave from Betelgeuse's explosion could compress nearby gas clouds, leading to the formation of new planetary systems, a process that has shaped galaxies for billions of years. Furthermore, the explosion will scatter heavy elements like iron, oxygen, and carbon into space. These elements, forged in the heart of dying stars, are the building blocks of life. In a way, we are made of stardust, remnants of ancient stellar explosions that once occurred in the distant past. Will Betelgeuse leave behind a black hole? One of the most intriguing possibilities is what remains after Betelgeuse's supernova. The fate of a dying star depends on its mass. If Betelgeuse is massive enough, its core could collapse into a black hole, an object so dense that even light cannot escape its grasp. Alternatively, if the remnant is not quite massive enough, it could form a neutron star, a bizarre ultra-dense celestial object where a teaspoon of material would weigh billions of tons. If a black hole forms, it could offer scientists a rare opportunity to observe the birth of a black hole in real time, a phenomenon never before witnessed by astronomers. What would Earth see? Despite being relatively close in cosmic terms, Betelgeuse's supernova would not be dangerous to Earth. At 650 light-years away, the explosion's radiation would not pose a threat to life on our planet. However, the visual spectacle would be unprecedented. If Betelgeuse explodes, it would outshine the moon and become visible even during the day for weeks or even months. Ancient civilizations once witnessed supernovae in real time, recording them as mystical omens in the sky. If Betelgeuse goes supernova in our lifetime, it will be a historic event, giving humanity a front-row seat to one of the most powerful cosmic phenomena.